In this video, we're going to talk about object-oriented programming in Go. There are a lot of things that really differ between Go and programming in C# or Java or C++. So I'll try to highlight some of the differences as I go and help you think about how to implement things really correctly using the features available in Go. So this UML diagram, Unified Modeling Language, is created with a tool called Raptor, and it's going to highlight various differences with three concrete types of bank accounts. So we're going to have a checking account, a savings account, and a money market account. Now, normally in object-oriented languages like Java and C# and C++, we would talk about parent classes and child classes. So we would have like some base account class, which checking account would inherit from. Go doesn't do that. Go instead does composition. So a checking account will contain a base account. It also doesn't have the same modifiers for public, private, protected, internal that you would see in other languages. It really only has two types of accessibility. We have things that are exported, which is basically the same thing as public. Those are things that are capitalized, like checking account. And then we have unexported things. Unexported is available only within the same package. So it's kind of like internal. And here we see that with base account, it's in lowercase. So therefore, it's only available in the same package. We see that also with balance and interest rate. Those attributes will be available only in the same package. Then the capitalized methods are all available externally, so they're exported or public. Another big difference that we'll see is the way interfaces work. So in C#, Java, C++, you implement an interface explicitly. So we would say that base account implements account. In Go, they use what's called duck typing. So if it quacks like a duck, it's a duck. So any struct that has methods for deposit, withdraw, and get balance could be cast to an account. All right, so let's talk about sort of the details of what we're going to be able to do with these accounts. So for all of our accounts, we're going to be able to deposit, get the balance, and withdraw. Savings accounts and money market accounts will additionally have an interest rate, which you can add interest to the account. The money market account will also have a withdrawal count. It will hard-code it, only let you make 3 withdrawals per month. And there's a method then to reset that at the beginning of the next month. The checking account also has this notion of overdraft. So when you perform a withdrawal from the checking account, if you're withdrawing more money than is available in the checking account, there can be a linked account which it will draw from if the checking account itself does not have enough money. And again, with the duck typing, we're not going to explicitly say any of these implement accounts, but all of them will, in fact, be able to be cast to an account interface because they all implement those methods either directly, as here in base account, or indirectly through containment. All right, so let's look at some slides to highlight these differences again. So in terms of accessibility, in Java, we have 4 different things: public, visible everywhere, private, protected in the subclass, and then if you don't say anything, that's the same as C# internal. It's visible in the same package. So that's unexported in Go. Go only has these 2, the public and the unexported. So there is no visible in the same class, visible in subclasses in Go. We just have the exported and the unexported. We talked about duck typing. If it looks like a duck and it quacks like a duck, it's duck. So we're not going to explicitly say a struct implements an interface. We can actually, and this is an advantage of this, we can easily add interfaces later to a type. We simply define the interface somewhere. Any type that implements those methods can be viewed as that interface. And that's especially nice if you're using a package from the standard library or something from a project you've downloaded from the internet or from some other team, and you don't want to be able to, or you don't want to bother to modify their code, but you want to actually use those structs with your interfaces. But this could lead to some confusion. You could imagine that you create a drawable interface That might make sense for things like triangle, but draw might mean something very different in the context of a gun in the Old West versus drawing a triangle on the screen. So we also talked about how Go uses composition as opposed to inheritance. So we don't say that a class or a struct inherits from or extends another class. We instead basically have each struct contain another struct. The Go compiler will actually allow us to do syntax that makes it look an awful lot like we're inheriting. So we can actually do var.method from the thing that we contain, or var.attribute. And so the syntactic difference will be small. There is a semantic difference of what the compiler is doing underneath the hood. Okay, so now let's go ahead and take a look at some Go code. We've got a package for bank accounts, and we're going to start with this interface. So we get this interface keyword, and we're going to say that account implements 3 different methods. That's sort of the contract, what you need to provide to be an account. You have to provide get balance, deposit, and withdraw. As we talked about before, float 64s are probably not the right choice here for precision. We're doing this for simplicity and printing these things out. You'd probably want to use an integer data type and actually always store your balances in terms of number of cents instead of number of dollars. Our base account will be a struct. It will contain a balance. And then this syntax here, where we have the parentheses and then the pointer to a base account. This is called a receiver, and this is going to give us that object.method syntax that we're used to from other object-oriented languages, and it'll allow us to do those kinds of calls. So get balance is going to take an account and no other parameters and return its balance. Deposit will again take in an account and an amount. If the amount is negative, it will return false. Otherwise, it will add that amount to the balance and return true. Withdraw will make sure that the amount is not more than the amount that's in the account, and it's not negative. In either of those cases, it would return false. Otherwise, it decrements that amount from the account and returns true. Now, in Go, there's 2 ways we can actually do containment. We can say base account, or we could say star base account. Star base account would actually store another pointer. That's probably not what you want unless you want to be able to swap out the base account for some reason. So if you're doing something that looks more like inheritance in one of the other programming languages we talked about, you're going to want to have this value here. Note, we don't give it a name. We just say the type. So it basically creates a field, which is we can reference it as base account of type base account. So all the attributes, all the methods will be available to the base savings account. And we're adding this float 64 interest rate. For the receivers, it's also possible syntactically in Go to omit this star. So we could actually do a value here as opposed to a pointer. So while we usually don't want to put a pointer here, we usually do want to put a pointer here. And the reason for that is because when we are passing a parameter to a method, that's going to be a pass by value. So we don't want to make a copy of an entire structure when we call a method. And we certainly don't want to use this value if we're going to change the contents of the struct, because we would be changing a copy. So we probably want to always be using a pointer here and never be using a pointer here unless you're in a much more advanced case. Okay, so we now have our method for getting the interest rate. You'll note here that for the savings account, we can actually just return this attribute, so bsa.interest rate. When we're adding the interest, we can say bsa.balance, even though balance comes from base account. So in some sense, this is really bsa.baseaccount.balance. But the Go compiler is going to be smart and let us skip saying that. So we can just say BSA.balance. So we take our interest rate, divide by 12 months, multiply that and add it to the balance to add interest. Our savings account will contain a base savings account. And then now for constructors, by convention in Go, you'll call a function new if it's a constructor. But when you have more than one struct in the same package, you'll say new and the name of the struct type. So here we're saying new savings account. We're going to return a pointer to a savings account where we have the base savings account containing the base account with the balance and then that interest rate. So we're sort of building up this struct and all of the things that are inside of it and returning a pointer to that. Our checking account struct will be a base account, but add an overdraft protection. And here we don't put a star because it turns out that an interface is basically always a reference. So it is already a pointer. Adding a star would be 2 levels of indirection. And so here we can actually store a nil if the user has no backup account linked. We're not going to have ever a nil for the base account because that is not a pointer. So this interface is a pointer and we can set it to nil. We'll see that here in this constructor. So we build the checking account with the base account and we're setting the pointer for the overdraft protection account to be nil. Here we have a constructor that will take in an account. Now that account, again, an interface is a pointer, so it will be something like a star savings account. All right, so then we put those two things in the checking account and return a pointer to that. Here our withdraw method. We'll check to make sure that the amount that we're withdrawing is positive. Here we can see that we can call withdraw from base account by saying ca.baseaccount.withdraw. So we try to do a normal withdrawal. If that succeeds, we're done. If it doesn't succeed, we already know the amount is positive, so that would mean that we're trying to withdraw too much money. So we check to see if we have an overdraft protection account. If we don't, we return false. If we do, we try to withdraw the deficit, the amount that we're trying to withdraw minus the balance that we have in our checking account. If we can withdraw that deficit from our overdraft protection account, we succeed. We set this balance to 0. If the backup account didn't have enough money either, we return false. So our money market account contains a base savings account and adds this withdrawal count because we're not going to allow a money market account to have more than 3 withdrawals per month. The constructor should look fairly straightforward. We build the base savings account and then add the withdrawal count to that. Now in withdrawal, if we see that the withdrawal count is already at least 3, that means we've done all the withdrawals we can for this month, we return false. Otherwise, we can again call the base account withdraw. So we're going to call withdraw from our base account. We could also here have done it from the base savings account. All right, so if that is successful, we increment the monthly counter. Otherwise, we fail due to insufficient funds. And we've got a couple simple methods here that return the number of withdrawals and reset that withdrawal count to 0. I have a demo program here. So the demo program imports that bank accounts, creates new savings accounts, checking accounts, and money market accounts. So here you'll see that using the colon equals means I don't have to specify the data type, which is a pointer to a money market account. We can print out the savings balance. And again, this is actually savings base account get balance. The compiler automatically calls that. Because it's unexported, we can't actually say here savings base account, right? This is lowercase, so it's only accessible in the same package. We can create we print out the balance for the checking and the money market account. We do these withdrawals. Each of these withdrawals returns true or false. I'm choosing to ignore those. Then I'm doing a fourth withdrawal from the money market, which should fail, and then I'm expecting that to return false, and I print out the balances. So just to highlight, if it quacks like a duck, it's a duck. We've never actually explicitly said any of those types implement account, but I could say var ACC account. So it would be bank accounts.account. And then we can actually then set that equal to savings. And we can print that out via the interface. So any one of our accounts would implement account, and so we can do that. So I'll go ahead and save that. Go build banking. All right, while we're waiting for that, I'll go ahead and show you the tests. So here we have a test package, import testing. One of the things that's new that I'm adding this time is the use of this testify package. Before, when we did testing, we saw a lot of if statements. This is going to simplify the syntax somewhat by using assert and require. So we build a table just like before. We have this run. We could additionally decide that we want to do something in parallel. Maybe we can say p.parallel, and then these tests would be run in parallel. We build the savings account, we do the deposit, and now instead of doing ifs and printfs and whatever, we can just say assert.equals. And if once success is not equal to success, it will, in fact, print out an error message. It will continue on to the next test. If we don't want that, we can actually say that we want to use this require. So we can say require.equal, and then this would mean that if this test fails, it will not bother to do this test. We have tests for withdrawal, right? So here we again loop through, we create the savings account, we do the withdrawal, we check that it succeeded or not as we expect, and that the balance matches what we expect. Here's our checking account tests with out of backup accounts and with a backup account. So we want the withdrawal to work without the backup account and the value be 60. Then when we withdraw 70, this should not work without a backup account. And so that returns false and the balance is unchanged. With a backup account, we have our checking account with 100, our backup has 200. We're going to withdraw 150. When this withdrawal happens, we should succeed. We've wiped out the balance in the primary checking and taken the missing 50 from the backup account. Then here we see that it should fail if we don't have sufficient funds in the backup account. So now we have 130. When we withdraw 150, that fails entirely. No amount is withdrawn from either of the two accounts. And then here, attempting to withdraw negative $10 doesn't change either of the accounts. This test, go through and try to withdraw a fourth time. That fourth time should in fact fail. Then it resets, and then it should go through on that time after we've reset the counter. And then here, a withdrawal that fails does not change the counter. All right, so we can go ahead and now run that banking. So you'll see that our account balance via interface, which we called on savings, does match the savings account balance. That worked. So if we want to look at what these tests look like, we can run the tests on the bank account. All right, so here are our results. So we get fail, we get a nice error message, right? So it says that bank account's a test go, 58, not equal expected true, actual false. So this is on a test savings account exact balance withdrawal. So let's look at what that test looks like. Oops, here we go. So this test, we're saying that we expected it to succeed withdrawing the entire balance, but it actually failed. So let's look and see why that happened. So if we look at our withdraw, we have the amount is less than or equal to 0. The balance is less than or equal to the amount. All right, so we can see we've actually made a mistake here in the withdraw method. We said if the balance is less than or equal to the amount, then we're going to return false. But actually, if the balance is less than the amount, right? So if they're equal, that's fine. So we can go build banking. And now we'll go run the test again. Right, now that you'll see that it's passed. Okay, so this has basically given us a nice introduction to how object-oriented programming or the containment features work in Go and interfaces. And we got a little bit of improvement on how our tests work with the testify package.